Great. Okay. So I've got like 10 minutes because together we've got 30 minutes and I want Aaron to actually talk more than me. So what I need to do is basically summarize about 10,000 years of philosophical tradition and about the last 10 years, give or take, maybe 8 years of work specifically in the ethics of machine learning into, literally 11 minutes. So I'll be as quick as I can. The introduction is the introduction is this. None of the stuff that has been that we've talked about this morning, which is really awesome. Tim's presentation, I missed Rachel's, Kate's around the sort of the ethics of AI. All of those things are fabulous, and they're really important steps towards us being able to deal with the problems that we're confronting and will be confronting in what happens with machine learning in society. But they're only sort of baby steps, and they're not the solution. So I can tell you right now, XAI is if not a dead end, then not the solution. And that's no disrespect to Tim. I've got like 2 papers in XAI that I'll sort of mention briefly. Aaron's doing some stuff on this, and it's just like, it's really, really hard. Like ethical precepts or statements at the OECD level or at the national government level or whatever around, this is what we stand for, this is what we do. It's like, yeah, sure. But what happens when you actually have to deal with it concretely? And so the process of FATML, as I still call it, these days they like to call it FACT, right? But it was Fairness, Accountability, and Transparency in Machine Learning. And the first conference was 2014. Give that some context, right? The Kraszewski and Hinton ImageNet, the radical paper it was around, that actually introduced convolutional neural nets to us and basically changed the world was 2012, right? So almost a year or 2 after this entire world changed for us with deep learning and the way in which it happened, we actually had people going, you know what, this is going to be a real problem. So why is it going to be a real problem? I'm going to try to click on this. There we go. All right. So the problem happened kind of here, right, when deep learning hit. Up until that point, this is my favorite slide of all time. It's not mine. I just ripped it off the net. I wish I knew where I'd gotten it from. But like all of the stuff that I was doing back here when I was doing AI and law, right, when it wasn't sexy, right, and now look at me and it is sexy, which is just, it's such an injustice, right? All of the stuff up to this point was basically symbolic systems, right? So you would create really, really elaborate rule bases that actually the machine could churn through. And then if you ask it, well, why did you do that? It goes, well, here is the rule trace, right? Like explanation was simply, here are all of the rules that fired. And it didn't matter whether you were doing, elaborate analogical systems as I was doing, for my PhD, and then actually looking at that within the PhD. It was really, really simple to say, well, why did you do that? And it says, well, this is the answer. It's just a set of symbolic reasoning processes, and the inferencing was really straightforward. But when we got to deep learning, we had, and this was, this is in literally the last 10 years, which is, I keep pushing on button. You'd think I know. When we finally got to this point where we're actually starting to build multi-layered neural nets that actually can do some really, really remarkable reasoning based obviously on prior massive data sets using these, fabulous mathematical mechanisms of actually embedding non-linear or linear functions, depending on the nature of the neural net, or in SVMs, where you're actually engaged in this type of extremely complicated mathematical parsing of prior data into actionable things right now, right, which is what's there. You ask it, well, why do you say that it's like this? And the answer is, we don't know, right, or I don't know, right? So the best example, the one I always use with my students is Uber used to have a self-driving car program. You recall that they stopped it. What was the straw that broke the camel's back? Well, they had all of these self-driving cars out there on the streets of Tucson, and one of them ran into a woman who was crossing the street while walking her bicycle. Right, and the reason that it didn't stop was that when they actually looked at what it was trying to classify this particular image as, it said initially deer ? Bicycle ? Bang. Right, and so there was a person dead as a consequence of that. And so the thing is that it's only as good, these models are only as good as the data on which they're trained and the algorithms which they're using. Now, when you look at, so that's the black box problem, right? When you boil it all down, that's where we are with all of this. As a consequence of that, we started to see, 2014 was the first conference around this, a lot of interest around, well, how do we actually deal with this problem of these essentially impenetrable black boxes, which are doing really, really valuable things. We could say we don't want them to do anything. That's not going to work, right? Because they're doing great stuff and they're extremely useful. But we actually have to find a way of dealing with this. So the response within the community, and this was largely driven by computer scientists. Occasionally, you started to get a few lawyers, a few ethicists, and now increasingly you get those sort of humanistic people into these, these HASS people into this STEM world. You actually started to say, okay, well, how can we divide this up? So the first category was fairness. Now, this came about largely as a consequence of a recognition. If you just do simple correlations like clustering of large data sets that actually end up in these ML systems and building these ML models, those data are terrible. Okay, the classic example is if you take the data of all of the recidivists, people that reoffend, right, based upon past data, and you happen to be in America, you will see that lots and lots of young black men reoffend. So if you're concerned about reoffending, right, and you are concerned about reoffending if you're a judge and you are handing out bail, right, or you are handing out parole or whatever, right, then you're going to say, well, it's not a good idea to give bail to a black 21-year-old guy. Right? It's just a really bad thing. That's actually terrible, because that should be one of the characteristics. Are they going to reoffend? That's a reasonable question to ask. But if you look at the data, like the reason why we've got lots and lots of data about reoffending 21-year-old black men is that they're arrested a lot because cops arrest black guys a lot, right? For standing on street corners doing nothing, for God help them, having a drink, or smoking dope. Smoking weed. Smoking weed on their stoop, right? And I lived in Brooklyn, right? And I could do anything I liked on my stoop in Brooklyn, like short of shooting somebody, and the cops aren't going to turn an eye. But if I happen to be like sitting while black, I'm going to be arrested, right? So we recognize very early on that the data sets are unfair. And if those data sets are then being processed into ML models, we've got a big issue, right? Now, the problem, and this is a great talk, I'd recommend you go have a look at it, that Ava Narayanan did, was like, it said, well, what do we mean by fairness? Right, I'll give you a really simple example. Is it fair for a government to tell me that I have to have a vaccine for the coronavirus? Well, right, if you care about bodily autonomy and the rights over yourself, you would say no. There's a lot of people that say that. If you care about other preferring issues like public health, you might say yes. But there's no one definition of fairness that you can go, well, there's the answer. Okay, so you have a whole series of contested ideas around what the hell do we mean by fairness? And that's where you have to invite in the HASS people, right? And so to come back to Tim's great observation, I loved his metaphor at the beginning of this, right? The inmates and the wardens, like we need people who are like well, I guess in a sense, like me and Aaron, and hopefully many of you who will be trustees, right? You're inmates, but actually you sort of have the function of wardens as well, right? Where you actually can bridge that divide between STEM and HASS. And it's really tricky because there is no one simple answer. So in the FATML, the other part of it was accountability. I could give you lots and lots of stuff around this. I'm going to try to do this really quickly. I actually took out all the slides that I had around XAI of all of the stuff that we do around this. I'll tell you right now, XAI is, because of the papers that we're working on at the moment, it's great, except there are so many different approaches to XAI, and none of them line up with any of the expectations around the law at all, right? Model independent approach methods like LIME don't fit with the legal system. They actually also don't work really well. Contrastive approaches or counterfactuals like Doshi Velez's work, amazing work, really amazing work. But actually, if you try actually operating it within various contexts, it's really not going to be very helpful. And I'll give you the really, really bad news. I did my PhD 100 years ago on the way that judges reason with cases. And you would think judges, they're like machines, right? This is all about justice. The way that judges actually reason about cases is they kind of go, that one looks kind of great. Okay, let me find an ex post after the event justification for why I should use that to say this is similar to that. And that's true across the board because that's how human beings work. So any of these sorts of approaches are going to be really problematic, are going to be really, really hard. The thing that I've stuck up there is Ken Hain, for those of you who actually follow the financial services regulation and compliance environment, which I do because I've got a couple of startups in that area. He came in and utterly, threw open the doors of this is really problematic around the way that banks deal with risk and compliance. So the example of all of the risk frameworks that Kate was talking about, we go, yes, this is really, really great. But if you actually go to the risk committees, which they did, and say, okay, so you're now relying upon AI models, ML models, to actually determine whether or not you are within a particular risk or not. And they say, yep. And you go, okay, well, tell me your confidence around that particular model, right? Have you actually validated that model? And they go, well, you can't really validate that model. And it's like, yes, exactly, right? Like there is no validation. There's no auditability of the model outside of the model itself. So you've got a major problem, and there are literally multi-billion-dollar decisions that are being made every day, right, or at least on a yearly basis in these big financial sector entities, right? And we've got no answer to how to deal with that. So accountability and auditability, major problem. The other component of FAT is transparency, right? Everyone knows, not everyone, many people know about the GDPR. Article 22 says thou shalt, if your GDPR is the EU regulation around this area, our equivalent is the Australian privacy principles, which are sort of worse, but not, not terribly worse, but they're just sort of, they don't kind of work quite as well. But Article 22 of the GDPR says thou shalt not impose a decision upon a human being under this particular regime, that is to say a European citizen, which is automated without recourse. And so a lot of people have said, well, that means that you've got to actually know how the system works. It's connected to the XAI approach, but it's also connected to sort of data agency and data autonomy. But again, no real answer to actually how that works. So even when the EU says this is actually a law that you've got to do something about, we actually don't really have any mechanisms to be able to say, we actually can have transparency over data because we don't really know. Then there's the whole other bit of ethics, because sometimes FATML is rendered as fate, right? And the ethics bit, I've just thrown up a couple of examples of there. Kate's already handled the sort of the autonomous drone sort of situation, but facial recognition or the trolley problem in autonomous vehicles. Each of these are really difficult human regulatory philosophical and legal issues that we can't just kind of go, there's a technical response to it, right? Because they are extraordinarily contested. They're really, really difficult. And also, and this is the other bit, which I love teaching facial recognition, because it looks like it's just a technical problem up until it becomes a human rights nightmare, right? Like it's just, you sort of think, oh, no, it's just like we're just doing some cool stuff. And then you kind of go, okay, there's this weird Australian guy who actually created this company called Clearview AI, and he scraped all of the tagged data from Facebook and has now created a model, a facial recognition model that allows law enforcement throughout the United States to be able to recognize anyone who's walking down the street at any time. Now, you kind of go, well, they're also really bad at it, right? It's really terrible that they're actually, misrecognizing people. And yes, that's true, but also, I didn't give them permission to be able to recognize me as I'm walking down there to an assignation with my lover or not, right? Like that's just not okay. And yet it looked like a technical problem, and now it's a massive human rights issue. So the scale of this particular issue is the fascinating thing, and it's a thing that we're grappling with at the moment. And that's my introduction to Aaron. Hopefully that actually gives us some context in relation to it. And thanks very much.
Thank you. We'll have some Q&A together at the end, which will be very shortly. So I'm going to talk about two projects in ADM+S that I'm working on with Dan and with some other lawyers in a little bit more detail of how we are looking to integrate these computational tools and then also humanities and social science sort of ways of thinking together to sort of hopefully make some progress in these areas. So first of all, overcoming AI opacity in tort litigation with my two colleagues, Dr. Henry Fraser and Raoul Simcock. We've alluded to it a few times today, but you would have seen in the news, I imagine, also about the incidents involving Tesla cars killing people in the US. This is not an isolated thing. It's been going on since at least 2018. There's been 12 crashes that have actually been under the control of the Autopilot software, and in particular have a proclivity to run into emergency vehicles that have their lights flashing on road networks. And this is obviously a problem. And right now in the US, there's a case that's being brought in a Texas court where the NHSDA and a bunch of police officers that were run over by a Tesla on Autopilot are trying to sue. They're trying to sue Tesla and suing them in product liability and in negligence. And that case is going to run into some really interesting difficulties because we know that Autopilot, for instance, uses a deep neural network for their object detection and their object classification component of their self-driving system. And so in these particular law regimes, you have to satisfy various legal tests before to convince a judge or a court that you have a case. And it's actually going to be quite difficult when this key component of the system that's driving this car is actually an opaque AI system. And so in this project with my colleagues, we're looking at trying to unpack this problem and then actually come up with a strategy that is perhaps a near-term potential solution, we hope. So there's a lot of scholarly work in this area that talks about regulation as a solution. So we need to change the law, we need to change the way that institutions interact with these big tech companies. We're trying to be quite pragmatic and say, if you got run over tomorrow by a Tesla, which has happened, obviously, how would you go about suing someone? And so, for instance, in common law jurisdictions like Australia or England or the US, we're looking at product liability as one promising line of action as well as negligence claims. And so there's a lot of previous work on product liability, but you may not only want to focus on that. And there's a couple of reasons why that is. Product liability, it's somewhat easier tests to satisfy in terms of like the legal tests, but it may not actually apply sometimes depending on the nature of the AI system. So if you have a software as a service type model, or you have software like the Teslas, for example, that gets updated over the air after deployment, it's actually unclear at this point if that falls under the regime of being a product. And obviously this varies with jurisdictions across the world. And so we've come up with this strategy that we hope actually allows you to try and satisfy the test for product liability and also negligence. And another reason, for instance, is there may be different time constraints. So negligence, you might be able to sue longer after the event compared to product liability, for instance. And so in this work, which is submitted to the FACT conference or about to be submitted to the FACT conference, we sort of describe a strategy where we can take a specific instance of harm. So in the Tesla case, there had to be 12 crashes before the NHSDA could step in as this regulatory body and say, okay, now we're going to bring an action against them. We want to actually take that 12 crashes earlier and say if there was one crash, how could an individual litigant now bring an action? And so you have a specific instance X, let's say, where there was harm caused. How do you generalize that to actually show there's a general pattern of poor behavior in this AI system? And we address these different steps in this strategy using different computational and legal approaches. So for instance, local explainable AI methods, Dan's just told you how terrible they all are, but they may have some application here where you actually can look at a specific data instance and try and reverse engineer or sort of figure out what are the features that it was relying on when it made that decision. And although these approaches are flawed, it may be the best that we can do tomorrow if you're hit by a Tesla, for instance. And so this is around, yeah, and then there's other legal approaches and argumentative approaches and different counterfactual reasoning things that go into this. But it's about trying to combine legal process and computational tools and doing that in a pragmatic way in the very near future and what that might look like to actually achieve justice in various situations. And then very briefly, with the remaining time, another project that we're working on with Dan and Anthony Skelton, a research assistant who's also online today, I think. We're looking at, instead of how can you overcome AI opacity if AI systems have harmed you and you're trying to sue big tech, for example, how can actually machine learning be used to improve the practice of law, for instance? And so law is a venerable social institution. It's been around for many, many years. Dan can talk better about that than I can. But it's also encumbered with lots of bureaucracy. It's slow, it can be costly. And so an example of that is family provision litigation is sort of a test case that we're looking at in this project, which is where you have a will that someone has died. They're trying to divide up the estate using the will, but it's contested. Maybe a family member comes out of the woodwork and says, I didn't get my share in that will. And so it goes to court and then a judge makes a determination as to what should happen to the assets of that estate. And so these cases, for instance, we know can run on for long periods of time, but in fact, they can actually consume up to like 50% of the estate in legal fees, just trying to resolve these disputes. They're hotly contested, they're highly emotional. And so it's a big opportunity there for automated models perhaps to help actually expedite justice and sort of improve the legal system. So this is sort of the other side of what we're looking at the ADM+S Center, is actually how does machine learning integrate with law practice. And so in this area, we have some interesting challenges. There's algorithmic conversion. It's really well documented in the literature. Judges don't want to be replaced by robots, neither do lawyers, for instance. There's a lack of structure in the legal domain, which is, I've actually found it really interesting this year, slightly different to other domains that I've worked in, like medical devices previously and medicine. So for instance, you could have a variable number of parties in a legal case. Like if there's a family provision case tomorrow and another one in a week's time, one could have one plaintiff and one defendant, one could have 5 plaintiffs and 5 defendants. And so your data is not actually uniformly structured, which a lot of data scientists sort of just assume that you have this neat data structure when you sort of jump into a new problem. But actually, this requires taking a step back and thinking, how do we actually model something that has variable sizes, but it's not sequential data like text or speech, for instance. It's not like a graph structured data. It's actually a little bit different. And then also somewhat shared with other domains, but a little bit unique again. We have lots and lots of data. Law, many court cases are in the public record, but the data is, I call it expert bound. So you actually need legal expertise to interpret court records, because the language that judges use when they write up, here's how I made my decision, as Dan was talking about, is very specific, and they'll use certain phrases which actually mean certain things to a legal expert. And so it's not enough actually in this context to ship this off to Amazon Mechanical Turk, for instance, A, because it's an ethical quagmire, but also B, it's not appropriate in this domain. And so in this project, we're looking at, again, leveraging litigation, existing litigation structures and processes to actually address these challenges. So one of them is something called a call to bank offer, which is an existing process where you can, before going to court, make an offer to try and settle outside of court. And if somebody doesn't accept that offer, then they have financial penalties potentially. So it's a tool that you can use to try and encourage someone to settle earlier without all the extra cost and time of going to a judge. And we think that by actually automating this, so call to bank offers currently exist but aren't used a lot because they lack evidence, they lack weight. I can say to you, settle now, give me this much money. But you might say, oh, if we go to court, the judge might rule in my favor. So why am I going to settle now when I have a better chance of winning? If we had a machine learning model that could predict ahead of time what is actually going to happen if you do go to court, that could add evidentiary weight. And so by adding this sort of predictive component, we think we can actually use this aspect of civil procedure to make this system more efficient. And then other ways to address algorithmic conversion in this area. So we're building a new system. So why make a black box system? There's this idea amongst a lot of data scientists that white box systems or classical AI is actually not as effective as deep neural networks, for instance. In my opinion, that is a little bit outdated, that worldview, and is perhaps shifting more and more. So there's very promising approaches that are extremely interpretable, but also extremely accurate. For example, NodeGAM is one that we're looking at. And then also leveraging shared autonomy. For lack of structure, there's various things we can go into there. Perhaps graph neural networks have a role to play, but I'll skip over that. The really interesting one is this issue of expert bound data. So we end up with very small data sets here because we have to pay an expert legal scholar to go and study these data sets and extract the data and code them. And so we're looking at self-supervised learning as a technique to approach this, where you actually can take a small data set and using pretext tasks and other technical approaches, still be able to train high quality machine learning models, even with tiny data sets. And this particular approach, the paper that I put on the screen, also works with some of these white box models that I was talking about. So we think that there's a lot of promise in combining these sort of contemporary explainable white box XAI type approaches in machine learning with legal practice. And there's cause for optimism, despite Dan's doom and gloom. And I'll stop there. Finally, a quick shameless plug. If you're interested in this kind of stuff, I'm actually running a workshop next week at NeurIPS on the political economy of reinforcement learning systems. We're going to be talking about power and money and how they interact with advanced AI systems. You can talk to me afterwards if you're keen. But any questions?